Hello class. In this video we're going to talk about reliability and validity, two ways that we can try to examine whether or not our personality tests are good tests. And not just personality tests, but any kind of test. Measures of intelligence, measures of memory, measures of what kind of jobs you like the best, any kind of individual difference that we're interested in psychology, any kind of test that we want to try to evaluate someone's score on, we want to make sure that those tests are reliable and valid. And last time I made a big deal out of this, and again, it's very, very important, but a test has to be reliable before it is valid. Reliability sets the upper bounds to which a test can correlate with anything else. Because reliability, essentially what we're doing is we're taking a correlation between the test and itself. And if the test doesn't correlate with itself very strongly, how the heck can it correlate with anything else? So we're going to talk about reliability and psychometric validity. So as I mentioned before, a test cannot be valid if it is not reliable. The reliability sets the upper bounds towards the extent to which a test can correlate with anything else. So let's say that we're looking at a measure of extroversion, and the reliability of that measure is 0.40. If the test can only correlate with itself at the level of 0.40, it can't correlate with anything else above 0.40. And in fact, it's probably going to correlate with something else a little bit less than 0.40, maybe 0.2, maybe something along those lines. So we want to make sure that the reliabilities of our measures are pretty high. If we want to be able to predict real-world things, the test has to be reliable. Also remember that personality is something that we think is consistent. It's something that's characteristic. It's something that's typical. So in multiple different situations across multiple time points, we should answer the same way on these personality tests. Otherwise, we're not really measuring personality. We're measuring something else, something that's more temporal. In psychometrics, there's this great idea known as classical test theory. And according to classical test theory, anybody's score on a test is a function of two things. So the score that they make on their test is a function of the true score. This is their true score on whatever thing it is that we're interested in measuring. Their true extroversion, their true hard-working ability, their true intelligence, if we're speaking about cognitive ability type test. But there's always going to be some error, and this error can be either positive or negative, and it's going to skew the results. So the true score might always be the same, your extroversion might always be the same, your intelligence might always be the same, at least for a brief period of time, but there might be some error introduced in this measurement. And we'll talk about what this error is in the next couple of slides, but think about it this way. Some days you take a test and you might be tired, and because you're tired, you might suppress your score. Some days you take a test and you might be energized, and that might inflate your score. Some days you take a test and you've had a full breakfast. Some days you haven't had anything to eat. All of these states are going to impact your score in some way. Maybe it's the case that you take a test in chemistry and they just happened to select test questions that you know all the correct answers to, just by luck. And the next day you take a different test and it's all the test questions that you don't know. So just the particular test items that they pick, it might randomly influence, and might mean that your score is higher than what it should be or lower than what it should be. Imagine if you take the SAT, for instance, and there's some vocabulary words. Maybe it's vocabulary words that you know. Maybe it's the vocabulary words that you don't know. I mean, over time, if you were to take the SAT or a test in some class over and over and over again, all of this error would cancel out. It's a random error. But if we take it one time, we don't know if that score is a little bit more inflated than what your true score is, or if that score is a bit lower than what your true score is. It's our job as psychometricians, as individuals that develop tests in psychology, to maximize the proportion of the observed score that is due to the true score. and minimize the proportion of the observed score that's due to error. We're trying to eliminate error as much as possible. And there's multiple types of error that we're going to encounter. Essentially, we're going to calculate a correlation coefficient where we correlate performance on the test one time to performance on the test another time, and that correlation coefficient is going to be called by another name. It's going to be a reliability coefficient. And if we have a reliability coefficient, let's say of 0.70, that means that 30% of the variance in that test, we're going to say, is attributable to true score, is due to the thing that we're truly interested in. 75 or 70% of the variation in that score is due to someone's true extroversion or someone's true agreeableness or whatever it is that we're measuring. And 30% is due to error. Maybe you had a bad day, maybe you had a good day, maybe the questions really spoke to you, maybe the questions didn't really speak to you. So that's how we are going to interpret a reliability coefficient. All right, so what is this error variance? We've talked a little bit about it. I've talked about some different kinds of error variance, but let me show you a few more examples of this and talk about two major types of error variance that we're going to get in our personality test. So let's say that we have the following question in a personality test. So I have all my Pokemon cards in a binder with protective sleeves. Agree or disagree? This is inspired by my middle school years. This was like illegal trading in the middle school courtyard, right? If you had a certain card, you had a lot of clout. So does this measure personality? And you might think to yourself, well, maybe, maybe not. So someone that is very organized is going to keep their Pokemon cards in sleeves. But so it does kind of measure whether or not someone is organized, but it also measures other things. It also measures whether or not someone actually collects Pokemon cards. So this one item is measuring a multitude of things, not just what we're interested in. It's measuring other abilities, other factors, other constructs. So this question is measuring both, do you collect Pokemon cards, and how organized you are. Let me give another example of this. Do you like to go dancing Friday night? Agree or disagree? Well, does it measure extroversion? Yes. Someone that goes out dancing is probably more extroverted than someone that doesn't. But there's many factors that might lead you to say no to that. Maybe you work on Friday nights. Maybe it's the case that you just don't like to dance. You would rather do some other social activity. So that question is measuring multiple things, not just extroversion, not just the personality trait that we're interested in. And this is the case with every single personality test or question that we can come up with. Okay, so here I have that we're measuring multiple things with this question about Pokemon cards. Here's something that I want you to remember. And this is as close to a law in psychology as there is. Any test in psychology, any measurement we take in psychology measures more than one thing. It measures more than what we're interested in. It measures multiple things. And that's problematic. This is different than some of the other sciences. As I mentioned before, if we're looking at chemistry, if we're looking at physics, we can look at the length of something, we can look at the volume of something, and for the most part, we're just measuring the volume or the length. But if we're asking a question about, how happy you are when you're around other people, how you respond to that question is related to a wide variety of factors, a whole slew of different things. It might, let me think of another example, but something like, do you like to go dancing on Friday nights, right? It's measuring many different things. Even a simple task like the Stroop task in psychology, where you see a word that's a certain color and you have to respond to the color, how quickly you can. It's a measure of your attentional ability, but it's also the measure of whether or not you can see colors. If you don't see colors, you're not going to be able to do that well at the task. It is a measure of your English ability. If you don't know the English language, you're not going to be tripped up that much in the Stroop task. So any kind of test that we create in psychology just doesn't measure one thing. It measures multiple things. But we can make our questions, we can write our questions so that they better able to measure a single thing. Instead of measure multiple things, they measure fewer things, or the majority of the variance in this question, in the scores of this question, are due to the trait that we're interested in. All right, here's another example of error variance. Well, maybe you were taking a test on how happy you are, and the night beforehand, you got into an argument with your significant other. And so that day, even though happiness is relatively stable, you might report being less happy, just due to a temporal state, just to the fact that something happened to you the night beforehand. Now, the day previously, maybe you got a new puppy. And if you got a new puppy, perhaps you're going to rate being more happy than normal. So there's all these states, these temporal states that might impact how we score on a personality test. Well, not just a personality test, but any kind of test in psychology. All right, how much sleep you got. There's many different things that might impact your score on these tests. All right, so there are two major sources of error variance in personality tests. One is temporary state error variance. So temporary state error variance, this is error variance due to the fact that you are in a particular mood. Something happened that's only going to affect you at this moment in time, but a day later it's not going to affect you, or a week later it's not going to affect you. So if, for instance, your score in agreeableness is slightly depressed because you got into an argument with your best friend right before taking the test, that's some error variance that's attributable to your temporal state. If you help someone that morning and you report being higher in agreeableness than what you typically would, that again, that's error variance due to a temporal state. Okay. Then we have multiple construct error variance. Every test question that we ask somebody for a personality test is measuring multiple things. So here's some other examples. Do you like to keep your apartment clean? Now this is measuring how organized you are, yes, but it's also measuring, are you in an apartment? Maybe it's the case that you have roommates and your roommates do all the cleaning and you don't. So there's multiple things that this question is measuring, not just how organized you are. How about, do you enjoy going to rock concerts? Yes, this is measuring extroversion, but it's also measuring how much you enjoy rock music. Maybe it's the case that you prefer country music. So these would not be the best items on a personality test. But even with any old item in a personality test, it's measuring multiple things, not just the trait that we're interested in. All right, so these are the types of error variance that we need to be cautious of, that we're going to try to eliminate as much as possible with our personality test. Another thing is, when we are assessing reliability, we want to make sure that we are accounting for these types of error variance. We want to see what our true reliability is, even in the face of multiple construct error variance and temporal state error variance. So let's talk about 4 different ways in which we can assess reliability of our tests. The first and the easiest way to assess reliability is with test-retest. Essentially what we do here is we take a test, we have subjects take a test today, and then we're going to wait a certain period of time. Maybe it's going to be 3 days, maybe it's going to be a week, maybe it's going to be a month, and then we give them the exact same test again. We take everybody's scores and we correlate their scores at time 1 to their scores at time 2. So why is it the case that your scores might be different from time 1 to time 2? Is it due to temporal state error variance, or is it due to multiple construct error variance? Well, the questions are exactly the same. So multiple construct error variance we're not able to measure here because, again, the questions are exactly the same. There's no reason why someone's score would be different because we're asking slightly different questions. However, time has changed. Maybe it's the case that you're feeling very happy this day because you've got a new puppy. Maybe you've got bad news on day 2, and so you're going to score a little bit differently. So the reason why your test scores would be different in these two situations is due to temporal state error variance. So test-retest reliability is accounting for, in that number, in that reliability coefficient, temporal state error variance. All right, let's look at another form of reliability. Here we have alternate forms reliability. With alternate forms reliability, we give everybody version A of the test on day 1, then we wait a certain amount of time, and then we give them version 2 of the test that has completely different questions in it. All right, why are these scores likely to be different from one another? Well, first, time has changed. So any temporal state that you're in, you're happy, you're sad, you're full, you're angry, might change between these two periods of time. So it's going to account for temporal state error variance. Another thing is that these questions are different. So if these questions might include things like, I enjoy going to a rock concert to measure extroversion, then maybe this question has something to do with, I enjoy going dancing Friday nights. All right, so because these are different questions, because these questions are measuring slightly different things, we might get a difference in the score. So alternate forms reliability is accounting in the reliability coefficient is accounting for both temporal state error variance and multiple construct error variance. And because of that, it's accounting for both of those types of error variance. Our alternate forms reliability is going to be the lowest. Our reliability is going to be the lowest because we're accounting for as much error as we can with this particular way of calculating reliability. All right. Way 3 to calculate reliability. Here we have split half reliability. For split half reliability, we give somebody a test one time. And then we look at the first half of their test and score it. And then we take the second half of their test and we score it. And then we correlate those two halves with one another. All right. So we do this. Is this accounting for temporal state error variance? The answer is no, because you're taking the test all at the same time. If you're mad while you're taking that test, you're mad for both of these scores. If you feel good during the test, you're going to feel good for both times here. All right, but the questions are slightly different. Because the questions are slightly different, this form of reliability is accounting for multiple construct error variance, the fact that these questions might not be measuring the same thing. Another way of looking at split half reliability, sometimes people call this a measure of internal consistency, the extent to which these test questions measure the same kind of thing. All right, so that's split half reliability. And the last one that we want to talk about is a little bit more complicated computationally. Instead of just calculating ye old correlation coefficient, we're going to do something slightly different. All right, with split half reliability, we take the first half and the second half. Sometimes we might take the odd items of the test and the even items of the test, score the odd items, score the even odds, and take the correlation. We're going to do something slightly different with Cronbach's alpha. With Cronbach's alpha, we're going to take the correlation of every single test question to every other single test question. So imagine, if you will, that we have a personality test that has 3 questions. It's not a good personality test because there's only 3 questions, but let's just say it for the sake of argument. We've got a 3-question personality test. And we're going to look at every single between item correlation. So we're going to look at how item 1 correlates with item 2. We're going to look at how item 1 correlates with item 3. And we're going to look at how item 2 2 correlates with 3. Sorry about that. Wasn't thinking. Hopefully this won't get pulled from YouTube. Okay, so why is it the case that, let me get back into the swing of things. Okay, why is it the case, sorry, got flustered. Okay, so we've got 3 different correlations here. These are all the between item correlations. Okay, 0.60, 0.70, 0.80. What we're going to do is we're going to calculate the average inter-item correlation. So 0.60, 0.70, 0.80, add them all together, divide by 3 because there's 3 of them, and we get Cronbach's alpha of 0.70. All right, so 0.70. This is the average inter-item correlation. Technically, at this point in time, we don't have what is truly Cronbach's alpha, but the average inter-item correlation is a good approximation of what's going to happen with Cronbach's alpha. So a couple more points. First, if we had a 4-item test, we would look at the correlation between item 1, item 2, item 1, item 3, item 1, item 4, 2 and 3, 2 and 4, and then 3 and 4. So we would look at all of those different correlations, take the average to get our average inter-item correlation. If it were 5-item, it would be even more. So you can imagine that this math would get quite onerous unless you had a calculator or a computer program to do this for you. There's one more step that we need to do to get true Cronbach's alpha. I want you to understand that Cronbach's alpha is similar to the average inter-item correlation, but there's one more step that we have to take. So the actual formula for Cronbach's alpha, what we do is we take this R hat here, R bar. R bar here is the average of all the between item correlations, and we multiply that by N, which is the total number of items that we have, and we divide it by the average inter-item correlation multiplied by N minus 1, and we add that to 1. If we do that, that gives us the true Cronbach's alpha. We have to account for the number of items there is in our test. Okay, it's a little bit of math. I don't want you to know this formula, but I want you to know that Cronbach's alpha is related to the average inter-item correlation. And the first step of going to calculate Cronbach's alpha, I want you to know that Cronbach's alpha is another measure of internal consistency. So it's not accounting for temporal state error variance because you are given the test all at one time. It's just one period of time. You take the test. We can calculate Cronbach's alpha based off of your performance. We're not getting you to come back another day. So it's only accounting for multiple construct error variance. And we're trying to see if all of these test questions are measuring the same thing or if they're measuring something slightly different. So Cronbach's alpha, a measure of reliability, but also we refer to it as a measure of internal consistency. Before we move on, notice the name Cronbach. This should be familiar to us. Cronbach, again, Lee Cronbach, this is the same guy that we talked about with differential and experimental psychology that came up with that, talked about that divide in the paper that you guys read. So Cronbach, very important here for psychometrics, very important psychologist. All right, so 4 different ways to measure reliability. So are all of these measures of reliability good? Are all these measures of reliability of equal quality? And the answer to this is no. It depends on what we're trying to measure. Again, the answer to the question is it depends. You knew that was going to happen. So certain forms of reliability don't account for all types of error variance. So split half reliability and Cronbach's alpha do not account for error variance due to temporary states. So you won the lottery that morning, you're feeling very happy. You got in a fight, you're feeling very sad. It doesn't account for that because we're calculating the reliability all at a single period of time. We're not getting you to come back in the lab where your temporal state might be something slightly different. All right. So if we wanted to account for both types of error variance, we would want to use alternate forms reliability. If we wanted to just account for temporal state error variance, we would do test-retest reliability. So if you look at papers out there, the vast majority of them, when they measure reliability, they use split half reliability in Cronbach's alpha. Why is that the case? Think about it. The reason for this is practical. Temporal test retest and alternate forms reliability, you have to come back to the test. You have to come back to the lab multiple times, at least 2 times, and take the test twice. That takes more time, that takes more effort. People have to show up on 2 separate occasions. It's much cheaper, it's much more efficient if you can just calculate the reliability if they come in the same exact day and they only take the test once. So you see people that equate Cronbach's alpha and split half reliability as being the true reliability of something, when in fact it would be better for us to do something like alternate forms reliability. But it's simpler to calculate Cronbach's alpha and split half reliability, so we see more people doing that. Is it always a good thing to have a high Cronbach's alpha or a high split half reliability? Now, I've said that reliability sets the upper bounds to which something can correlate with something else, so you would think, yeah, it would be good to have the highest Cronbach's alpha. And in many circumstances, this is the case. But remember, Cronbach's alpha is a measure of how consistent all the items are. Are they all measuring the same thing? If we have a test that's very narrow, that we're measuring something very specific, well, we imagine all the test questions are going to be measuring the same thing. But if we're measuring a trait that's very broad, something like general intelligence, we wouldn't want to have a high Cronbach's alpha. We would want to have a lower Cronbach's alpha. Because for general intelligence, you can't just include items about vocabulary, you got to include items about vocabulary and math and spatial reasoning and a whole ton of other things for it to truly be general intelligence. So we would expect our measures of internal consistency, Cronbach's alpha and split half reliability, to be lower. So if we have a very broad construct that we're interested in measuring, we wouldn't want Cronbach's alpha to be too high, to be in the 0.9 range, and so forth. What is a good reliability for a test? Well, the textbooks are going to tell you if you have a reliability of 0.70 or higher, the reliability of your test is acceptable. That's a good 1 point to say if it's higher than that, then you're good to go. But really, it depends. Really, it depends on the discipline that you're in. Some tests, it's easier to get a higher Cronbach's alpha than others. When you're in the field of memory and attention, where all of your items are very similar to one another, it's very easy to get a very high Cronbach's alpha. But when you're looking at something like personality, which is a whole lot more messy, it's going to be harder to make that cutoff. So it really depends the discipline that we're in. It really depends on what we're trying to measure. We're measuring a really broad trait, or are we measuring a very narrow trait? All right. So how do we improve our reliability? Let's say that we calculate our reliability and our reliability is trash. It's in the 0.4 range. Well, we need to do something to improve it. What are some things that we can do to improve our reliability? Well, one thing that we can do is we can standardize our research protocol. Maybe it's the case that the instructions were explained slightly differently both times. Maybe it's the case that some subjects, some people heard different instructions than somebody else. So one thing that you can do is try to standardize the administration of the test as much as possible. Maybe by having a computer report the instructions to the participants, maybe by clarifying things from the beginning of the experiment, make sure that everybody understands it fully, and there's not some people that are really struggling to understand these things. But if you standardize the research protocol and make it consistent every single time, your reliability is going to go up with your psychological measures. Use unambiguous language for your items and your questions. So let's say that you have the item, I feel excited before taking a test. I feel excited before taking a test. Now, excited could mean a few different things. Excited could mean, woohoo, let's get ready to take the test. Many people would say false if that were the case. But my family uses excited sometimes to mean nervous or anxious. So I feel excited before taking a test. Maybe that you are interpreting that to mean I am anxious before I take the test. So people could interpret this question in many different ways. And that's not good if we want to have good reliability, if we want to have good validity as well. Maybe it's the case that you interpret excited one way the first time that you take the test and interpret it a different way the next time that you take the same exact item. So we want to use unambiguous language in our test questions to ensure that we have good reliability. If we measure a narrower trait, something more specific, we're going to have better reliability. The broader our trait is, the less likely we are to get a good reliability. As I mentioned, general intelligence is very broad, and we have to take questions from all kinds of different disciplines to include it in that test. If we are measuring how much you enjoy being around new people, that is a very narrow trait compared to something more broad like extroversion. So do you like to be around people? An extroversion, one's more narrow, one's more focused, the other one is more broad. We're going to get higher reliability if we have a narrower trait. All right, so conscientiousness, which has to do with both how hardworking you are and how organized you are. It's a very broad trait, but we can contrast this with something like cleanliness. Cleanliness is more specific. We're likely to have a higher reliability for the narrower, more specific trait. All right. The last thing that we can do, and this is a surefire way to increase the reliability of our test, is to increase the number of items there is in the test. If we increase the number of items in the test, it is going to be more reliable. There's just more opportunities for the person to report a certain answer. And if the questions have some multiple construct error variants, the more questions that you have, the more likely that is to all average out. In fact, there is a mathematical relationship between what the current reliability of your test is and what would happen if you double the number of items. What would that do to your reliability? What would happen if you halved the number of items? Maybe your test is too long. Would your test still have a good reliability if you halved the number of items? You took half of the number of items. This formula is called the Spearman-Brown prophecy formula. So let's type that up. Prophecy formula. So the Spearman-Brown prophecy formula, this is a mathematical relationship between the current reliability of your test and what would happen if you change the number of items. We can predict using this formula, hence the term prophecy here, what the reliability of your test is going to be. This is a very useful formula. For instance, if our test is too long, we want to make sure that if we halved the number of items, would the test still be good? Still have adequate reliability. If the reliability of our test is not so good, maybe if we doubled the items, what would our reliability be? All right, so this is what we do if we have a problem with reliability. All right. So let's move on and talk about validity, specifically psychometric validity. Remember, psychometric validity is the extent to which we know that our personality test measures what we think that it measures. Okay? What's the extent to which our test measures something that's of importance? All right, and there's many types of things that are called validity in psychology. One example of this is what's known as face validity. Face validity is the extent to which a test seems, and that is at face value, to measure what we think that it measures. It's the extent to which the test seems to measure what we think it measures. Here's a good example of this. So in graduate school, we tried to measure multitasking for the Navy, and we helped develop and use two different kinds of multitask here. One is a measure of air traffic control. So what the subject has to do for this test is planes are going to land every so often, and you need to make sure that the runways are clear for landing or clear for takeoff. And while you're doing that, you're also watching this radar and letting pilots know if there is any disturbances in this radar, if there's any blips that the pilot should be aware of. And while they're doing both of these things, they also have to do this code book. And they have to translate these symbols and these numbers and select the correct symbols and numbers over on the right-hand side. And there's lots of rules that they have to do that. So as you can imagine, this is quite difficult. This seems like it has to do with multitasking in the real world. This seems similar to what an air traffic controller would do. All right, let's compare that to this test over here. This test over here is called SynWin, or synthetic work. What you have to do for this test is first you see these letters, and these letters go away. Every so often there'll be a probe letter that appears right here, and you have to say, is it a letter that you saw initially in this string of letters, or is it a different letter? So you're having to do that when this letter pops up. You're also having to solve math problems. All right, you're having to do some subtraction and some addition. Another thing that you have to do is this fuel gauge is constantly ticking down, getting closer and closer to red. Your job is to refill the fuel gauge when it starts to get low. You get more points the closer it is to 0, but if it reaches 0, it starts taking away some points from you. And that's not all. There's another component of this test. For this part of the test, you are constantly hearing noises, and if it is a certain beep of a certain frequency, you have to press this button. So you're doing all of these 4 tasks at the same time, responding to this when you see the letters, responding to this when you hear the beeps, making sure the fuel gauge isn't too low, and when you're not doing that, you're solving math problems. This seems very different than what somebody would do in real life. This test seems to not have very good face validity. Okay, one test seems to measure something of importance, seems to measure what we think that it measures. The other test doesn't seem like it measures something of interest, doesn't seem like it measures something in the real world. Now, which one of these tests actually does the better job of predicting multitasking ability? Which one of these is the better multitasking test? And it turns out that it's synthetic work and not this one. Face validity, it has to do with what the test looks like, but it isn't a true measure of psychometric validity. A test could have horrible face validity and look horrendous, but do a very good job of predicting real-world abilities. A test could seem very similar to what people do in the real world and be a horrible test. So face validity is not a true form of psychometric validity. It's nice to have it, but it's not the end-all be-all. There are other types of validity that are much more important. Face validity is important to something that we should consider when we're creating our test, and this is known as rapport. Rapport is the bond between the experimenter and the person taking the test, the examiner and the examinee. If the examinee thinks that this test is useful, they're likely to try their hardest. And if they try their hardest, their data is going to be good. And the data for our test is going to be good. We can accurately measure whatever it is that we're trying to measure. If they don't think that the test is very important, they're going to goof off. So there has to be some rapport that's established between the examiner and the examinee. If I show up to the lab and I'm wearing a white lab coat, if I am taking the study very seriously, then the examinee is going to take the test very seriously. If I am in a holy t-shirt and cut off shorts, the examinee might not take the test as seriously. If the test looks like maybe it's the case that it measures something important, well, then people might spend more time taking it. They might spend more attention taking it. They might do a better job of taking the test. However, if it's the case that the test seems nothing like what they do in their job or real world, and they don't understand why this is important, well, then they might blow off the test. So rapport is important. Don't get me wrong. Just face validity is not ultimately as important as psychometric validity, and there's some other very important measures of psychometric validity. All right. So Lee Cronbach and Paul Mill, in this famous paper that I'm going to put in the optional readings or in the optional folder for D2L, came up with 3 major types of psychometric validity. Now, Cronbach, again, a name that you should be familiar with. Same guy that wrote the paper about the difference between correlational and experimental psychology. Same guy that came up with Cronbach's alpha. Here we have a paper outlining 3 major types of psychometric validity. And because Cronbach and Mill hated undergraduate students trying to learn this, all 3 forms of validity start with the letter C. This is content validity, criterion validity, and construct validity. If I were a betting man, this is something that you will get confused. Do not do that. Learn these, be able to distinguish these, because this is very important. These are how we determine whether or not a test measures what we think that it measures. So it's very important that you are able to distinguish these types of validity and are able to enumerate these different types of validity. All right, so let's go, what are these different types of validity? Content validity. This is the extent to which the test measures all of the relevant subcomponents of what it is we're trying to measure. Imagine, if you will, that we're trying to create a test that measures your high school math ability, or high school math achievement, rather. What you learned in math in high school. If I only ask questions about right triangles, I'm not fully measuring everything that you learned in math in high school. I'm measuring something. I'm measuring one specific thing you did in geometry, but I'm not measuring algebra. I'm not measuring the rest of geometry. I'm not measuring trigonometry and other things that you learned in high school math. So I'm only measuring a subset of it. That test would not have good content validity. To have good content validity, we would need to measure all the different types of things that you learned in high school about math. How about a measure of anxiety? To be a good measure of anxiety, we don't just ask questions about how anxious you get for tests. That's one component of it, but we also want to talk about anxiety in the workplace, anxiety around other people, anxiety when you're back at home, anxiety when you're on a job interview. We don't just want to ask questions about test anxiety. So we need to measure all the relevant subcomponents of the tests. Here's my example of high school math achievement. All right, so that's what we do. How do we ensure that our test has good content validity? There's 2 things that we can do. One is we look at theory. We look at a theory of a particular construct, maybe anxiety, maybe extroversion, whatever it is that we are trying to measure. And we look at that theory and we see what are the subcomponents of that trait or of that construct according to the theory. And we make sure that our test covers all of those different subcomponents. So we look at the literature, we look at the theory of what we're interested in, and make sure our test is measuring every subcomponent of that. Another thing that we might do is we go to a content expert. We go to someone that truly knows something about what it is we're trying to test. And we make sure that they are comfortable with the kind of test questions that we are given. So for instance, I've mentioned before that my wife works at Home Depot, and one thing that they helped create was a test to assess for people that would apply to a job in which they would loan out tools to other people, the tool rental place. Sorry, there's probably a better name for that, but we're going to go with that for right now. So the tool rental place. So we have to select for someone that would do a good job there. So we have to ask them questions before they're hired about all different kinds of tools and what you need for certain jobs. But obviously, the people that create the test might not know that much about tools. They might not know the kinds of questions that people would come into the store asking. So what they did is they took people that were very successful in their job at the tool rent center place, and they got them to write down the skills that someone that was going to be an expert at this job would need to have. And then they created test questions based off of those skills and then gave them back to the content experts and made sure that the content experts were cool with them. And then they moved forward with creating the test. So we might look at content experts. How about our test of high school math ability or our high school math achievement? We might ask some teachers that teach high school math to make sure that we are covering everything that they cover. So we might go to content experts. We might look at theory to make sure that we have good content validity. Next form of validity, psychometric validity, is criterion validity. Criterion validity is the extent to which a test measures something in the real world, measures something important to the real world. If our test doesn't correlate with anything important in the real world, then why are we bothering creating this test? So our measure of extroversion should correlate with how many social events somebody goes to. Our test of agreeableness should predict how many fights somebody gets into, whether or not you're likely to spend time in prison. All right. Our measure of neuroticism should predict how many times you experience anxiety, how often you go see a counselor. All right, so it's the extent to which our test predicts real life performance, real world phenomena, real life outcomes. There's two ways that we can assess criterion validity. And these are predictive validity. So predictive validity and concurrent validity. Let's define these. Predictive validity, what we do is we measure people's personality. We measure whatever it is that we're interested in. Maybe it's a cognitive ability, maybe something like intelligence. And then we see, does that correlate with an outcome that's going to occur later on? Is it the case that your personality at age 5, does it predict whether or not you're likely to go to prison when you're in your 20s? Does your score of extroversion predict how many clubs you're a member of when you get to college? All right, so we're measuring personality, we're measuring some individual difference, and then we look at the outcome later on. So what are some examples of this? So I've mentioned whether or not we predict whether or not something like agreeableness predicts whether or not you end up in prison. Extroversion predicts how many positions of leadership you have, how many social events that you attend, maybe how hardworking you are. Does that predict whether or not you end up with a higher paying job? Does it predict whether or not you're more likely to be employed? Does it predict your supervisor ratings as to whether or not they think that you're a good employee? All of these are examples of criterion validity. Specifically here, predictive validity. We're trying to see if the measure predicts these outcomes. All right. So predictive validity is great, but to measure predictive validity, this takes time. You got to measure personality, and then you got to wait for things to happen. And sometimes we want to create a test quickly. And sometimes we can't wait 15 years to see whether or not you end up in prison before we can say whether or not this test is psychometrically valid. So another way of assessing criterion validity is concurrent validity. Here we have two groups or multiple groups of different people that there's already some predetermined distinction between them. Maybe we have individuals who have successful marriages and we have individuals that have unsuccessful marriages. And we give them all the same personality test. And then we see whether or not that personality test is able to distinguish between the two groups. Does the test discriminate between these two groups? Now, let me give you an example of some research that I did in graduate school. So we were interested in predicting who would be a good translator for the military. And we didn't want to, first thing, give everybody this test and have everybody go through this training and then see who succeeds and who fails. That would take a lot of time. That would waste a lot of money. So what we did is we took individuals that were already successful translators for the military and some individuals that were already unsuccessful, that did not do well at the program, and gave them all a bunch of tests. And then we saw which test distinguished between the two groups. And those tests we assumed were going to be the best predictors of who was likely to get through the translator training program. Okay, we did this research at CASTLE, the Center of the Advanced Study of Language. Some pretty cool, a pretty cool research study. All right, so we took two predetermined groups. We gave them all a test and saw whether or not the test distinguished them. If the test does a good job of distinguishing those two groups, we've got good concurrent validity, which is a way of measuring criterion validity. Again, criterion validity, the extent to which our test measures something important in the real world. Lastly, yet another C, construct validity. Construct validity is the extent to which our test is correlated with things that it is supposed to be correlated with and is uncorrelated with things that it is not supposed to be correlated with. For many psychometricians, this is the most important type of validity. We need to make sure that we have good construct validity. There's two important components to construct validity. There's the extent to which the test correlates with other tests that supposedly measure the same thing. This is called convergent validity. And there's the extent to which the test is uncorrelated with things that it is not supposed to be correlated with. And this is called either divergent validity or discriminant validity. It's the extent to which the test is uncorrelated with things it's not supposed to be. So let's give some examples of convergent and divergent or discriminant validity. If you come up with a new test that supposedly measures extroversion, that test of extroversion should measure extroversion in the Neo Personality Inventory, a famous personality test that we'll talk about a little bit later on in class. It should also be correlated with extroversion in the MMPI, the Minnesota Multiphasic Personality Inventory. Both of these have extroversion subscales. If your test of extroversion is uncorrelated with these, well, guess what? You've got a problem. If you come up with a new test of intelligence, it should be correlated with the Stanford-Binet. If it's uncorrelated with the Stanford-Binet, well, guess what? We got a problem. All right, so that's convergent validity. Let's look at divergent or discriminant validity. Does your test correlate? So divergent validity, it is the extent to which our tests are uncorrelated with things that they're not supposed to be correlated with. So for instance, if we have a test of intelligence and it is more strongly correlated with how much money someone's parents make compared to whether or not it's correlated with, I don't know, things like the Stanford-Binet. So we create a new intelligence test. It's more correlated with how much money your parents make as opposed to the Stanford-Binet, another measure of intelligence. We've got a problem here. The test is measuring something that we have a problem with. It's measuring something that it's not supposed to be. All right. If our measure of extroversion is also very strongly correlated with how hardworking a person is, we've got a little bit of a problem here. So to have good construct validity, we need to make sure that that test is correlated with measures of the same trait and that it's uncorrelated with measures of different traits. Okay? Individual differences that are not supposed to be correlated with the test, they should hopefully be uncorrelated with our tests. All right, so that's a lot of different types of validity. To help you out, I created this handy guide. So 3 major types of psychometric validity. We've got content, which is the first that I talked about. I showed this to another class and they got really messed up because I've switched the order in here. But we've got content validity, which is the psychometric validity that we're measuring all of the relevant subcomponents. We've got criterion validity, which is the extent to which our test is correlated with real world outcomes. We can measure it 2 different ways, with predictive validity and concurrent validity. And we have construct validity. This is the extent to which the test is correlated with things it is supposed to be correlated with and uncorrelated with things that theoretically it's supposed to be uncorrelated with. Convergent validity is the extent to which the test is correlated with things it's supposed to be correlated with. Discriminant or divergent validity is the extent to which the test is uncorrelated with things it's theoretically not supposed to be related with. All right, that is a lot of important information. But anytime we create a test, we don't just come up with a test in personality and say, boom, this is good, it's perfect, I don't need to worry about things. Before a test is useful, it needs to go through a rigorous process where first we're testing the reliability, we're shaving off questions, we're only selecting the questions that have the best reliability, and then to validate the test, we see whether or not the test measures all the relevant subcomponents. We see whether or not the test predicts real-world performance. We see whether or not the test correlates with other tests of the same thing, and whether or not it's uncorrelated with things it's not supposed to be. I mean, that's a huge endeavor, and it's one of the reasons why a lot of these standardized tests cost so much money. There's a lot that goes into making sure that the test is both reliable and valid. All right, so let's end there. We'll talk plenty more about reliability and validity when we talk about specific tests later on in the course. All right, well, I hope you have a good day, and I will talk with you later. Bye-bye.